Welcome to this tutorial. I'm solving question number 8 of paper 21 October-November exam series of 2021. The question says a loudspeaker is made from a coil of wire fixed to a cardboard tube. The tube is attached to a cardboard cone. Figure 8.1 shows parts of the arrangement of the loudspeaker. When there is a current in the coil experiences a force. State what else is needed in a loudspeaker to make a current carrying wire experience a force. So a force is experienced when a current carrying wire or conductor is placed in a magnetic field. So a magnet or magnetic field is required here for this current carrying wire to experience a force. The next part says a student connects the coil to the output of an alternating current or AC generator. Figure 8.2 shows how the EMF produced by the generator varies with time. So this EMF is showing that we have an alternating EMF applied to the coil, and one cycle is completed for this signal in 0.005 seconds. The coil, tube and cone vibrate backwards and forwards. Explain why the EMF shown in figure 8.2 makes the coil vibrate. So the EMF shown is telling us there is a positive half cycle and then there is a negative half cycle in the EMF signal. So when the positive half cycle of the EMF is there, there is a flow of positive current, and when the EMF changes its direction to the negative half cycle, there is a negative current flowing. So when the current continuously switches its direction, the force being exerted on the coil placed in a magnetic field also changes. So the answer would be the current in the coil continuously reverses direction, and the force on the coil continually reverses. So when there is a force in one direction, it might move forward. When there is a force in the opposite direction, it might move backwards. That is why this whole arrangement is moving or vibrating backwards and forward. The next part says the vibrating cone produces sound in the air. Explain in terms of molecules how the cone produces a sound wave that travels through the air. So when the cone moves forward, air is compressed, and when it moves backwards, air rarefaction is produced. So we have continuous production of compression and rarefaction. So production of compressions and rarefactions continues. That is why there is sound produced in the surrounding. Sound is a longitudinal wave. Describe the difference between a longitudinal wave and a transverse wave. So in a longitudinal wave, particles of the medium vibrate parallel to the direction of propagation of wave, while in transverse they are vibrating perpendicular. So in a transverse wave, particles vibrate perpendicular to the direction of propagation of wave, and in longitudinal, they are parallel. Using figure 8.2, determine the number of times that the cone reverses its direction of motion in 1 seconds. So we can see that one wave is completed in 0.05 seconds. So it means the time period of the wave given is 0.05 seconds. Now we can use this to find the frequency. So when 1 divided by 0.005, so the frequency comes out to be 200 Hertz. So in these, so 200 Hertz tells that there are 200 waves in 1 second, and each wave has a positive cycle and a negative cycle inbuilt. So it means that the direction of the wave is changing twice the number which is showing us the frequency. So it is 400 times per second where the direction of motion is changing. Now the next part says the speed of sound in air is 340 meters per second. We are given with the value of the speed. We have to calculate the wavelength of the sound. So V is equal to F lambda is the formula which would be used here, and lambda, the wavelength, would be equal to speed divided by the frequency. Speed is 340 and the frequency is 200. So the answer we get is 1.7 meters. The wavelength of the sound here is 1.7 meters. The next part says the student adjusts the generator so that the maximum voltage of the output is now 3 volts. Everything else remains the same as the output shown on the figure 8.2. Explain any effect on the loudness of the sound. Now, since the maximum voltage is decreasing, before it was greater than 3 volts and now it has been reduced to 3 volts. So the new pattern for the wave would be like this. So we have a wave whose amplitude is 3 volts now, and the amplitude has decreased a little. So the decrement in the amplitude shows that there is decrease in the energy, and when there is decrease in the energy, the loudness decreases. So we would say that loudness decreases because loudness is proportional to amplitude, and when the amplitude decreases, the loudness decreases because the maximum force on the coil decreases. So because of the decrease in the value of the EMF, the current is going to decrease, and the force which it was previously experiencing would also decrease, and that would decrease the loudness of the sound. Explain any effect on the pitch of the sound. So there is no effect because frequency is not changing. So we would say that pitch remains the same because pitch depends on the frequency of the signal. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.